So in this unit, we're doing the reverse of what we were doing prior to now. We're going to try to find the original function given that we've already gotten the derivative. So if you see something like this, integral 3 dx, that means the derivative with respect to x has already been taken. So if you think about that, that has to be a 3x, because if you take the derivative of 3x, you get 3. Now the problem here is that there could have also been a constant that we took the derivative of and got 0, and there's no way without further information that we can find what that constant is. So what we do temporarily until we know more information later is we just say plus c. So this would be 3x plus c. Now, that gives you the first rule. If you have the antiderivative or the integral, okay, this is called the antiderivative, opposite of derivative, basically. It's also called an integral, and that's an integral symbol of a constant with respect to x. It's going to be kx plus c. So that's your first property. Any constant is just going to have a variable to the first power. And then, of course, we always have to add the plus c to stand for if there had been a constant. For example, if our original function was 3x plus 12, and we take the derivative of that, we get 3 because the derivative of that's 0. So we have no way of knowing without further information. That's where the plus c comes from. Number 2, we're going to take the integral of 16x plus 5 dx. Well, there's a property that says if you have more than one term that you're taking the derivative of, you can take the derivative of each one separately. So since 5 is a constant, we know that's going to be a 5x, and we know we're going to have a plus c. Now 16x, we're going to need to reverse the power rule. So remember what the power rule said. If you have x to the p, we did p times x to the power minus 1. So we've got to add 1 to the power and divide by the power. So it's going to be x to the power you see plus 1 divided by p plus 1. So we have a 16. That x is to the 1, it's going to be to the 2, but we have to also divide by the 2. So let's look at that. That's 8x squared. Now think about that. If you take the derivative of that, it would be 16x. So our answer is 8x squared plus 5x, and again, plus c. So we have 8x to the second plus 5x plus c. So that's your second, that's the second property, this property right here, that when you have any variable to any power, when you integrate that, let me write that out for you. If we're going to take the integral of x to the p dx, the dx means the derivative has already been taken, it's going to be x to the p plus 1 divided by p plus 1, because we reduced it by 1 and multiplied by that. And then, of course, plus c. So for number 3, we have, I'm going to go ahead and separate them, 6x squared dx, and each one needs this differential dx. That's the thing that says we've already taken the derivative. So you have to make sure that when you write it as separate terms, that you write that dx with all the terms. And then plus integral 2 dx. So this last one, of course, is going to be 2x because that's a constant. Don't forget your plus c. This one is a power. Now that 5 is just going to come down. You're going to add 1 to the power, and then you're going to divide by that. So that's negative 5 over 2 x squared. And this one's going to be add 1 to the power 3 and divide by that 3. Now you can always check, let's reduce this, 2x cubed minus 5 halves x squared plus 2x plus c. You can always check by taking the derivative to make sure it matches this. Of course, you can't determine what the constant is, at least not yet. So 2x to the third minus 5 over 2 x to the second plus 2x plus c. Number 4. Now, when you have a root, you need to write it with the fractional exponent, and then you can use that power rule I just showed you. So we've got 5 square root of x dx plus square root of 3 dx. So this one's going to be the square root of 3x because the square root of 3 is a constant, and then there's plus c. Now, if I'm going to do 5 square root of x, I'm going to write it 5x to the 1/2. So I'm going to have to add 1 to that, and I'm going to have to divide by the whole thing. 1/2 plus 1 is 3/2. A little bit of fraction work. The 2/3 gets flipped over, so it's 2/3 times 5x to the 3/2. So it's 10/3 x to the 3/2. Let's take the derivative of that just to show it. So it's 3 over 2 times 10 over 3 x to the 3/2 minus 1. Well, look, those will reduce out. 2 goes into 10, leaves a 5, so it would be 5x to the 1/2, or 5 square root of x. So it's 10 over 3 x to the 3/2. 10 over 3 x to the 3/2. Remember, write it as a fractional exponent, 1/2, add 1 to it, divide by that 3/2. Divide by a fraction means you flip it over and multiply. So our final answer for this one was 10 over 3 x to the 3/2 plus the square root of 3, that was a constant, so it's just times x, plus c. All right, so now we have one that has been factored, and what you want to do here is you want to multiply this out, 7x to the 4th plus 14x. All of that has the differential dx, so that's 7x to the 4th dx plus 14x dx. So we're going to get 7x to the 5th over 5 plus 14x to the 2nd over 2 plus c. And of course, this second one will reduce to 7x squared. So it's going to be 7/5 x to the 5th plus 7x squared plus c. Just multiply it out before you take the integral. Question number 6, we have the integral of 8x to the negative 3 dx. So in this case, I want you to write any variable in a denominator that's a monomial factor, just one term. It can be moved to the numerator with a negative exponent. So to take the integral, you're just going to add 1, and then you're going to divide by that number, and then it's going to be plus c. So that's 8x to the negative 2 divided by negative 2. So it's negative 4x to the negative 2 plus c. So, and if you wanted to, you could write this without the negative exponent, negative 4 over x squared plus c. It should take it both ways. I'll go ahead and write it this way. Since they started out with positive exponents, I'm just going to leave it with positive exponents for my answer.